Contributors in the field of science, 500 BC to 600 BC. Thales of Miletus circa 624 BC, circa 546 BC. Thales of Miletus, often regarded as the first philosopher and scientist, made foundational contributions to mathematics, astronomy, and physics. He proposed that water was the fundamental substance underlying all matter, a theory that marked a shift from mythological explanations to naturalistic inquiry. Thales is credited with accurately predicting a solar eclipse, demonstrating the potential of scientific observation and prediction. He also introduced geometric principles, including Thales's theorem, which laid the groundwork for Euclidean geometry. Thales's emphasis on observation and logical reasoning helped to establish the scientific method. In addition to his work in astronomy and geometry, Thales contributed to engineering, devising practical solutions for measuring distances and heights. He believed in the interconnectedness of nature and sought explanations based on natural phenomena rather than divine intervention. Thales's inquiries into magnetism and static electricity foreshadowed later discoveries in physics. As one of the 7 sages of Greece, his wisdom extended to ethics and governance, influencing broader intellectual traditions. Thales's legacy endures as a pioneer who bridged philosophy and science, inspiring future generations of thinkers. His exploration of astronomy led to improved calendar systems and methods for navigating at sea, influencing trade and exploration. Thales's work also provided insights into measuring time using shadows, a precursor to sundials. His contributions remain a testament to the importance of practical application combined with theoretical knowledge. Anaximander, circa 610 BC, circa 546 BC. Anaximander, a pre-Socratic philosopher and scientist, advanced early theories of cosmology, geography, and biology. He proposed that the universe originated from a boundless substance called the apeiron, marking a departure from traditional creation myths. Anaximander's cosmological model depicted Earth as a free-floating cylinder surrounded by celestial rings, offering one of the first mechanical explanations of the cosmos. His work in geography produced the earliest known world map, demonstrating a systematic approach to charting the Earth's surface. Anaximander also speculated about evolution, suggesting that life began in water and gradually adapted to land. His studies in meteorology examined the formation of wind, rain, and lightning, promoting naturalistic explanations for atmospheric phenomena. Anaximander's contributions extended to geometry, where he refined measurements of time and space. His emphasis on observation and theoretical reasoning influenced later philosophers, including Anaximenes and Pythagoras. Despite the fragmentary nature of his writings, Anaximander's ideas anticipated modern scientific concepts. He also designed an early sundial to measure time and developed theories explaining seasonal changes. Anaximander's approach to celestial motion and planetary cycles served as a basis for astronomical research. His work on the evolution of species hinted at the principles of adaptation and survival, foreshadowing later evolutionary theories. Heraclitus, circa 535 BC, circa 475 BC. Heraclitus, a Greek philosopher and scientist, is best known for his theory of constant change, summarized by the phrase, "You cannot step into the same river twice." He viewed fire as the primary element and a symbol of transformation, reflecting the dynamic nature of existence. Heraclitus emphasized the unity of opposites, arguing that conflicting forces sustain harmony in the universe. His exploration of change and continuity influenced later studies in physics and thermodynamics. Heraclitus also examined the role of logos, reason, as the guiding principle of order and knowledge, promoting rational inquiry into natural phenomena. He explored the properties of heat, light, and energy, laying conceptual foundations for modern physics. Heraclitus's reflections on human perception and cognition contributed to early theories of psychology. Despite his cryptic writing style, his insights resonated with later thinkers, including Plato and Aristotle. Heraclitus's focus on transformation and interconnectedness continues to inspire interpretations in science and philosophy. He proposed theories on the movement of celestial bodies and cycles of natural disasters. Heraclitus emphasized the interdependence of elements, highlighting the delicate balance in ecosystems. His ideas foreshadowed modern ecological concepts and systemic thinking. Xenophanes, circa 570 BC, circa 478 BC. Xenophanes, a Greek philosopher and poet, made significant contributions to natural philosophy and theology. He challenged traditional views of divine beings, proposing a monotheistic concept of God as an eternal, unchanging force. Xenophanes observed fossils embedded in rocks, leading him to theorize that Earth had once been covered by water. This hypothesis anticipated later geological studies on the history of Earth's formation. He emphasized the role of evidence and reason in explaining natural phenomena, distancing himself from mythological interpretations. Xenophanes' critiques of anthropomorphic gods reflected a scientific approach to understanding existence. He also studied atmospheric processes, examining the formation of clouds and precipitation. Xenophanes' interdisciplinary approach integrated philosophy, geology, and meteorology, promoting empirical inquiry. His writings influenced subsequent philosophers, including Parmenides and Heraclitus. Despite his focus on rational explanations, Xenophanes maintained a deep respect for tradition and cultural values. His work encouraged skepticism and intellectual independence, shaping the foundations of scientific and philosophical thought. He explored oceanic fossils to understand ancient climates and geological changes. Xenophanes also discussed the cyclical nature of natural events, which influenced geological time theories. Parmenides, circa 515 BC, circa 450 BC. Parmenides, a Greek philosopher, made profound contributions to metaphysics and logic, influencing the development of scientific reasoning. He argued that reality is unchanging and that change is merely an illusion, challenging perceptions of motion and transformation. Parmenides introduced deductive reasoning as a method for establishing truth, laying the groundwork for formal logic. His poem, On Nature, explores the relationship between being and non-being, emphasizing the importance of rational thought over sensory experience. Parmenides' ideas about permanence and unity influenced later studies in physics, particularly concepts of space and time. He also examined the structure of arguments, promoting clarity and consistency in scientific discourse. Parmenides' rejection of empirical observation highlighted the need for theoretical models to explain natural phenomena. His work inspired later philosophers, including Plato and Aristotle, to refine theories of matter and existence. Parmenides' emphasis on logic and abstraction continues to resonate in modern scientific methodologies. His exploration of infinity and continuity influenced theories of calculus. Parmenides also examined the metaphysical structure of the universe, shaping ideas about atomic theory. Thank you for exploring the remarkable contributions of these ancient scientists and philosophers. Their groundbreaking ideas laid the foundation for modern scientific thought and continue to inspire curiosity and exploration. If you enjoyed this content, please like the video and subscribe to our channel for more educational insights. Don't forget to hit the notification bell to stay updated with our latest releases. Your support helps us grow and share more knowledge. Thank you.